Yeah. So I think you'll be able to see my screen. So we will discuss. We don't really go in depth of Active Directory, all like domain controllers and stuff like that. Mainly, we will focus on DNS, how actually DNS works. So our main objective will be, let's say, understanding. Uh, I hope you can see my screen, right?
Yes.
Okay. So our main objective would be, let's say, you are using your laptop and you open a browser. Then when you open a browser, you do a google.com. Let's say you want to actually search something in Google, you type google.com in browser. So when you type google.com in browser, you get a Google homepage. So that's all you know. But what happens in the under the hood? What happens in the backend? So when you actually type google.com, what exactly happens? How do you get that homepage? How all these things will work? So that's what we are going to understand now. So that's the main objective of this, AD, Azure Active Directory. I mean, DNS is part of it, so that's how you see the title. But so let us actually see something. Yeah. So you basically see a domains like this, Microsoft.com. Then you'll also have some subdomains, child.microsoft.com, grandchild.child.microsoft.com. So this is a main domain. We call it as forest. This is actually subdomain, child.microsoft.com, because it's actually part of it. Then you have, this is again considered subdomain itself. So the domain structure will look like this. So domain is something, uh, yeah, again, domain is something that will consist of some users, groups. So it's basically to actually have some domain controller, you'll have this domain setup. Yeah, I think for a DevOps engineer, domain setup, users, groups, most likely you really may not deal, but you might deal with the DNS. You might need have some. You'll definitely have some need of understanding DNS, because when you configure an application, when you deploy when you actually build an infra, and then when you deploy the code there, so to access that, you'll most likely you'll use a URL. So how that when you actually use the URL, how actually you get your application web page. So that's something there will be some need of understanding that. So to actually explain that, let me actually bring something. Okay. So yeah, so you're actually on your laptop. Okay, so you actually typed, let's say you typed google.com. Okay, so you typed google.com. And that Google Doc. So you are actually on your laptop, but you have some internet connectivity for your laptop. How you got the internet connectivity? So you get internet connectivity basically with a network interface card, as I told you. That network interface card will get an IP address assigned. You definitely would need a broadband connection or any Wi-Fi hotspot or anything as such. That is when you'll be able to connect to an internet, right? So you have a broadband connection in your home. Let's say Act Fiber, and then Act Fiber has you actually you connect it to the Wi-Fi, and then you got some IP address to your machine. So ideally, you get a public IP address. So that's how you connect to internet. There will be two types of IP address, public and private. So private is something within your premises that doesn't go out of your premises, that doesn't communicate with the uh, internet. public is something will actually communicate with the internet. It is part of internet. It will communicate with the internet devices. Okay. In fact, all smart devices will have a public IP address assigned. Be it a smart fridge, smart AC, smart any smart device will have this public IP address. In fact, your smartwatch also will have. So that's actually true. So all smart devices will have they will communicate with the internet. They'll have some, I mean, not only just internet, they'll actually communicate with the other devices. They get an IP address assigned. So you actually tried a google.com in your browser, and when you try this, where will you got a Google homepage? Let's say you got a Google homepage. So let's take this as an example. Okay, I'm actually doing google.com. I got my homepage, but you don't know how you got this homepage. All you know is just you are looking for Google, you got the homepage, but how exactly you got this? So let's open a small command prompt tool, a command prompt tool. Let me actually make the font big so that you guys can see it. Yeah, I think now you can see it. So let me do ping google.com. This is the ping device which actually will help you in checking the connectivity with the destination server, whatever, Google or anything. Ping microsoft.com. So microsoft.com, you may not be able to ping because it doesn't, maybe there may be a reason, but google.com is very widely we use it. Let's actually try bing.com. So let's see, I don't know if Bing, yeah. So Bing is actually competitive for Google, right? So definitely you'll be able to. So like you're able to ping google.com, you're also able to ping bing.com. Okay. So when you ping this IP address, when you ping this name google.com, you got some IP address, right? You got some IP address. I have actually a different machine. This is actually located in South India. I also have a different machine. It's actually located in Central India. The one machine is in Chennai. Another machine is in actually Central India, which is Pune. So let me try to ping from here and let's see will I get same IP address or not. Let's just only for our comparison. So I got 172.172.217 here. I'll explain why I'm actually trying this. So here 204. So let me switch to another VM. Sorry. Here I got 142 and 13. So both are different. So this is actually located in Central India. So this is located in Chennai. This VM is located in Chennai, and sorry, and this VM is located in Pune. So when a user from Pune actually tries to ping google.com, he got a different IP address, which means he got a different machine. And when a user sitting in Pune, when he tries to do, he got a different machine. Now let's actually go back, try to understand what's happening in the backend. Okay. So when you actually do when you actually try to ping bing.com, when you actually, I just pinged it, but when you actually do a bing.com, like you did a google.com. You go to Bing search, Microsoft Bing search. So what happens? So first of all, your request will go to your gateway. There, every laptop will have a gateway IP address. So you'll have IP configuration. Along with IP configuration, you'll also have a gateway IP address. So how do you see that IP gateway? So when in your command prompt, you just simply type for IP config. So you get some IP. This is actually not a this is actually private IP address, but you'll have some public IP address setup. So this is what I mean by this is a gateway. So any communication that goes out of your network, out of your machine, will actually go through this gateway. That's why the name itself is a self-explanatory gateway. you have a gate to your home. When you want to go out or come in, you come through that gate itself, right? Similarly, so every machine will have a gateway. So when any communication that want to go out of your machine or come inside to the machine will actually happens to this gateway. Then this gateway will actually connect to your router. So this setup. So that gateway basically will be so that's actually a gateway. Then it will go out of this gateway and then it will go to your router. So this is your router. Every home will have a router, right? So that router will actually take a request. When you search for bing.com, that router will actually look for a what happens is there is something called DNS entries, DNS servers. So every when you actually want to connect to any website, you basically you will connect via IP address. That's actually true, but it's not really possible to remember all the IP addresses. So that is the reason we got the naming conventions like google.com just to make it easy. It's something like this. In your mobile, you have thousands of numbers, mobile numbers. Do you really remember all the mobile numbers, or you just remember the names? We don't remember mobile numbers, right? We just remember the names. And what you do, you actually will store all the numbers along with the names. Then whenever you want to call someone, you search with that name and you'll call directly. So because you already saved with that's actually mapping. You actually mapped that mobile number with a particular name. When you actually dial that, when you actually dial with that name, you get a call connected to the mobile number, right? Similarly, in the internet world as well, so every machine will have an IP address. Every website will have an IP address because so a website will be ideally built on top of a physical server or a virtual machine, right? So that virtual machine, when you actually build a website, that website can be accessed by the IP address of that virtual machine, wherever it's built on top of. Let's say it's built on a one server. That server has certain IP address. Let's say this is the IP. Bing.com is actually built on a particular server. That server has this IP address 104.12.46.88. So that IP address belongs to that machine. Ultimately, when you want to connect to the bing.com, you should be able to reach this IP address. Only then you will get your web page. If you're not able to reach this IP address, what I mean by reach is you should be able to access this IP address. How do you check the connectivity? So this is how you check the connectivity. So when you ping something, you get some ping request, the response back. So that's actually I mean by the connectivity. We are able to reach this IP address. That's what I mean. So I can show you something in a simplest terms. So this is the IP address I copied. Let me go back, go to Google browser. Let me actually use this IP address. Let's see what happens. Do you see the magic? So I actually did not type google.com. I just simply typed that. I just simply use this IP address, whatever I got in the ping. I got my Google homepage, right? So let us actually look at the other machine. So I got some response here, some different IP address. Let me use this IP address. Same browser. I'm using different IP address now. Let's see what happens. I got the response, right? So actually Google, I'm going to actually explain why you're seeing different IPs and what's happening later. But what I'm trying to convey is, so ultimately, when you're able to reach the IP address, only then you get your web page to you. So, but because in this internet world, it's not really possible to remember all the IP addresses. It's not really possible to remember all the IP addresses. That is when the DNS concept has come in picture. DNS is nothing but domain naming system. So that domain naming system will actually map, just like your telephone directory, the way you map mobile numbers with particular names, you also can map your IP addresses with a host names. We call it as host name. When you say google.com, it's actually a host name. You're mapping the google.com with certain IP addresses. You're mapping bing.com with certain IP addresses in DNS entries. That's actually DNS is part of Active Directory. So you actually, that's a role in Windows. You enable the role and you actually it's not only available in Windows, it's also available in Linux. It's also available in different variety ways. So whenever you purchase, whenever let's say you own a domain, you want to own one domain. you purchase one domain. That domain, you purchase a domain. From where do you purchase the domain? Most likely you'll go to some like websites like GoDaddy, Namecheap, Cloudflare, Google domains, Microsoft App Service domains, AWS domains. So these are all domain registrars. They'll actually sell the domains to you. So when they sell a domain to you for some certain price, so that price will be an annual basis. You most likely will pay 500 to 1,000 rupees on annually. You get your domain to you. When you want to open a startup, you purchase it. You have to purchase a domain to build a website or anything as such, right? So you get a domain to you. The domain will have its own DNS entries, DNS servers. That's what I mean. So it will have its own DNS servers. Okay, I'll give you one simple example. I own certain domains. I'll show you those domains. Let me give some other different password. So let's go to DNS Jones. So I own these 3 domains. So let's look at this domain. So this domain will have some records. These are called DNS records. We call this as DNS records. You see DNS records here. You see various different. You don't actually. Being a DevOps engineer, you don't actually need to create any records, manage anything as such. But all you just need is understanding. So all you just need is understanding how actually it works. That's all you need to understand. You don't have to set up anything from scratch. Just listen, try to understand. As long as you understood, I think we are good. Initial few days, just understanding is required. You don't actually have to set up anything in your actual day-to-day works. Okay, so this is all you maintain certain records. Here I'm maintaining some record for this a record. So this is actually called mapping. So when you want to map some certain thing, so let's say you will actually map like this. So you'll give this domain with certain IP address. Like in this case, if you have a google.com, you give a google. Here you will see google.com, and you give a lot of IPs, whatever IPs that you want to actually redirect to. So like this, you actually will map things. So this is how it look like the domain DNS entries. I don't have any GoDaddy setup. That's why I'm sure, but I have some Microsoft domain DNS setup. So I'm showing this to you guys. So this is how the DNS setup will look like. DNS, when you actually purchase a domain, how do you purchase a domain in Microsoft? So you search for a domain, you get something called app service domains. So you will be able to purchase the app service domain. So okay, so here in my case, I don't have any subscription. My subscription is disabled. But when you actually search for these domains, it does actually search. Let's say I'm searching for this domain. So it will actually show you available domains. It says this domain is not available, but it is saying these are the available domains. In case if you are interested, you can go ahead and take. So the price for each domain will be 12 USD on annual basis. So you have to pay annually 12 USD. So close to 800 rupees it might cost. Not 800, maybe more than that, 900 plus. So that's how it actually costs you. So this is how you purchase a domain. Why I'm actually talking about purchasing a domain is when you actually want to, when we talk about google.com, the google.com is also a domain that's actually that has its own DNS servers, because end of the day it's a domain that's actually, maybe Google has its own registrar, so they actually take domain directly from there, but they will the google.com will have a DNS entries. That's all I'm actually trying to convey. So now we know that Google actually has a DNS entry, but when you're actually trying to connect google.com from browser from here, what happens immediately? The request will go out via your, out via gateway of your NIC. Then it will go to your router. In router, there will be a DNS entry setup. So DNS, we call it as DNS cache. So in DNS entries, it does actually check for google.com. So it will check google.com whether google.com has any entries. It's kind of a directory. In the simplest terms, it's like a telephone directory itself. In olden days, you have a big book, telephone directory book, where you actually try to map stuff. So you look at, if you want to see in those days, if you want to see Chiranjeevi's number also, you directly go and look at a telephonic directory, and then you will be able to identify. Those days, the privacy is actually gone there, but in those days you will be able to see it. That's how the directory, the names are used to manage. Similarly, your domain registrars also will actually maintain this list, who actually purchased the domain, what is the IP address, what is the records, all those details it will actually maintain. So now this, when you actually do it from here, your router will actually look for those details. If your router, what details it will look for? It will look for that google.com. Is there any DNS entry for google.com in this local cache, in this router cache? If it finds, it will immediately respond back with that IP address. So if it doesn't find that information here, then it will immediately go to your provider. When I say provider, it's actually I did not find a symbol, so I actually have put this. But if you I said Act Fibernet, I use Act Fibernet. So that Act Fibernet network ISP network provider, it will go to ISP network provider. This ISP also, they'll also have certain DNS resolvers. When resolver is nothing but when you actually do a google.com, it should be able to resolve. When it resolves, you'll get one IP address, the way we got some IP address here. If you don't get any IP address, it's you'll not be able to connect to google.com. So it will actually resolve the IP address, and if it actually again, it will try to look for the entry, the DNS entry. If it finds, it will immediately reply back to router, and then via router you get that you get that IP address, and then you will be able to, you'll see your homepage, Google homepage, whatever you're seeing here. If it doesn't find here also, then it will go to root server. So I talked about domain. One simple slide, let me show. Yeah. So this is what I want to show you. So this is actually www.google.com. So there are certain things that you need to understand in this is, yeah. So actually this is actually google.com request that you're doing, but there is something that is hidden, is this dot. So every website, when you actually do a google.com, there will be one dot at the end. That is something we don't really, maybe we will overlook at it, but you'll see a dot. Every domain will have that. Okay, a dot. So the dot itself, I'm actually trying to represent separately. This is actually hidden most of the times. Okay, so here in this case, this dot is actually root. That dot is actually root domain, and then this .com is actually top level domain. You see .com, .in, .org, multiple different .gov, .gov, .in. This is called top level domain. This is called top level domain. Then you'll have actual domain, like google.com, Google, Wikipedia, Microsoft, Amazon, Microsoft. Yeah, again, Google again, it has come 2 times. Okay, so this is actually normal domain. Then whatever you see here, so you see www dot, that's actually subdomain. Sometimes you see something like this, like drive.google.com, drive.google.com for Google Drive. You see maps.google.com for Google Maps. You see Office 365 for Microsoft also. You'll see different teams.microsoft.com. You'll also see portal.azure.com. You'll see portal.office.com. You'll see domains like this. So in this case, these are all actually subdomains, just like your www dot subdomains. These are all actual domains. These .coms are actually top level domains. So, but something that is missing here is the dot. The dot is missing here. So for every domain you see these dot. These are actually root domains. So these are kind of hidden. Most of the time we don't look at that. So this is how the domain structure will look like. This is how the domain structure will look like. Now let us actually go back and try to understand little further what exactly happens. So this will actually look for the entry. If it actually finds the DNS entry, it will immediately respond back to your router, and then via router you'll get that response back to your laptop. The moment it gets a IP address, you'll be able to access that IP address. You get your homepage, Google homepage, automatically. You'll get that homepage. But in case if it doesn't find it here, then it has to go to root server, google.com root server. For google.com root server will be .com. For maybe Indian government.in, something like that, some income tax returns.in, something like that. So all those will have, each of these will have its own domains, gov.org, wikipedia.org. So these are all called root domains. In our case, if you are doing google.com or bing.com, so you go to that .com root server. So that .com root server, there it will actually it will look for certain IP. It should have some entries, DNS entries. What DNS entries I'm talking about? I'm actually talking about Google DNS entry. For Google, there will be some host name, IP address. That IP address it should be able to find. In case if it finds, well and good, it will immediately respond back to that. What happens the moment it finds that IP address, it will actually share that IP address here, and that's how you will be able to reach. But in case if it doesn't have the details either, then the next last thing you have is top level domain. This is top level domain is something. Sorry, this is actually root server, google.com root server. Yeah, I think this top level domain is actually .com. This is actually not root server. This is normal name server. Sorry, guys. This is just a domain that google.com and that stuff. And then top level domain, there is something missing, guys. Okay, 1 second. Yeah, in .com it will actually look for, and here this is actually here this is where you'll actually look at. This is where you'll see dots. The dot, whatever I say, the root. So this is actually top level TLD only, top level domain only. So 1 second. So this happens in a reverse way. So let me explain you what I mean by reverse way. It will actually where is that slide? Yeah, it happens in a reverse way. So it look at the dot, and then in a dot you'll find a .com DNS entries. Then in a .com DNS entries you'll find Google DNS entries, and in Google DNS entries you'll get your IP address. So that's what we are actually trying to do. So when your ISP providers ISP provider doesn't actually able to get a DNS record, then immediately it will actually look for this the root server. In a root you'll definitely get entries for this .com, .org, .in, .gov, all these details. And then from there you will get in a let's say you get a .com DNS entries. Then you go to .com DNS server. In .com DNS server, that's what we are doing. That's what we are doing. In root server, you get DNS entries for .com, .in, .gov, .gov.in. And then from here, you go to .com DNS server. This is a top level .com DNS server. And here you get entries for your google.com. That google.com entry is something you get. That google.com entry, most likely, you will see an IP address. That IP address belongs to your domain registers, whoever actually sells your, whoever actually, that DNS entry, most likely you'll see the DNS entry wherever you host it or wherever you purchase a domain. Then you will find the google.com DNS entry, the final DNS entry, the IP address of google.com. What I mean by that is this IP address, this IP address. Finally, you'll be able to map this google.com. You get this IP address. That IP address will be sent back to your root server, and then will be sent back to root server, and then to your ISP provider, and then to your router, and then to your computer finally. So this computer will actually maintain that information as a cache. Not only computer, your router also will maintain that information as a cache. Not only router, but also your ISP provider. So what happens in that case? This maintains this information as a cache. This router actually maintains that information as a cache, and then you get your IP address. With that IP address, directly you'll be able to connect to that IP address. You get end of the day, your google.com will be hosted on some server. That server IP address you got, and you're able to connect to it. Then you get your home page back. This is what happens. And another thing is, when you get this entry details, your router actually maintains that as a cache. So when it maintains as a cache, the cache will remain for at least 24 hours. So the 24 hours time, you have another laptop where you also want to do a google.com. Then it actually, because in your home, all devices are connected to same router, right? So when you want to do a google.com, it actually go to this router, and then it actually, because there is some cache information, the DNS cache, it actually provides the IP address to you. Immediately you connect to it. That's how it works basically. But all of a sudden, if this machine actually changes its IP address, so instead of 10.2.104.12.46.88, it's changed to some 80, 89 or 90, and you have, but your DNS, this router actually has a cache as this 88. For 24 hours time, when you have the cache something like this, you'll not be able to connect to it, because 88 machine is not available, or you only have 89, that website. Then that's when you actually experience some problem because of local DNS caching. So in that case, you have to flush the DNS and register the DNS. So there are a few commands that you can run, but the troubleshooting, most likely you don't have to do, because as long as you just understand how actually it works, the DNS will work. That should be good enough. Do you guys have any questions, doubts? Okay, so you guys understood very well, or you guys did not understand? So let me know, so that I know. If you want me to explain again, I'll do. Are you guys able to understand about the DNS concept? How actually, I'll cover this different IP setup again, but now I'll cover that now. But I just want to understand how this, look up the IP address when you actually type a name, how you actually get your page. Are you guys able to understand that?
Yes, it is clear. Only one thing I wanted to ask you. Said IP address will change at the server.
That doesn't happen in production. That doesn't happen in production workload. I'm only just saying that as an example. But in production workload, they don't change the IP address easily, because that will cause huge business problem, business loss. So they don't change any IP address in production. Just an example, I'm saying that.
Okay.
Yeah. Are you clear, please?
Yeah, I am clear.
Yeah.
How about others?
So we are seeing two different IP addresses, like you have shown. Like when you're running it from the southern part of India, you're getting a different IP address, and from the central, if you do it, you're getting different. What is the reason for that then?
So because Google, you know that Google actually gets millions of requests, right? Yeah, Google doesn't actually just get a few requests. So most of the time, to serve all the requests, they will actually maintain multiple servers like this. So they'll actually maintain servers like this. They'll maintain multiple servers in the backend. So each server will have its own IP address, right? So what they do is they'll actually maintain some load balancing mechanism. They'll actually balance the load across these multiple VMs. So you'll have a load balancer. So this load balancer will actually balance the load. So sometimes what happens is these, sorry. Come on. Yeah. So you get a request like this. So you'll have this load balancer. You will actually, your computer will be somewhere like here. Sorry. Your computer will be here, and you will actually try to access. So you get some load balancer IP address. This load balancer will actually balance your load across these multiple machines. I am only showing 4 machines here, but Google will have hundreds of machines in the backend, because they will get close to millions of requests, right? So to serve all the requests, they don't use one single big machine to serve all the requests, because when that machine goes down, your Google's website will be down, right? So to avoid that, they will maintain multiple similar machines, smaller machines. So each of these some machine may locate somewhere close to South India, some machine may locate somewhere close to Central India, some machine may locate in US, some machine may locate in UK, London, Singapore. In every country, Google has its own data centers. So they will actually store these. They will actually create those servers, similar servers, and a user actually, so this load balancer will have certain mechanism, load balancing mechanism. So a user requesting from India, or a user requesting from Chennai, will get a machine that is closer to Chennai. A user requesting from Pune will get a machine IP address that is closer to Pune. A user requesting from Hyderabad, he will get a closest machine from Hyderabad. So that's why you're seeing the different IP address here. So like this, Google will actually maintain. Let's say if you're in a different part of if you're in a different part, let's say I only tried from Chennai and Pune, but I am actually located in Hyderabad. So let me actually try it in my machine and see what happens.
Yes.
Oh, wonderful. So I got some, I got some, IPv6 IP address. When I do a Google ping google.com, I did not get an IP address. In fact, I got some IPv6 IP address. So this is actually, I'm not sure whether you guys are aware of it, but we have IPv6 as well. So that's actually introduced because IPv4 has some around billion or odd IPs. So, but outside in the market, there are a lot of devices are coming in. So those most of the IPs are already allocated. So we only have certain few IPs few IPs available. So because of shortage of the IPv4, IPv6 was introduced. IPv4 works with decimal, like you'll be able to read in numbers, but IPv6 works with hexadecimal. I'm not sure, are you guys aware of binary, decimal, octa, hexadecimal? So that's actually uh, yeah.
Yeah, we are. I mean, I'm aware of this.
Yeah, so IPv6 actually has got a hexadecimal number. So when you have hexadecimal, this actually will have IP. I'm actually we have the IP address, set up as well. IP address basics session as well. Most probably on next Saturday I'll cover that. That's actually very important topic. Um, so there I am actually going to cover what is IPv4, how actually IPv4 the decimal, how the decimal will be calculated from binary, how you can convert it to binary. So there are a couple of important details there. So and why we got IPv6 now? Because IPv6 actually IPv4 offers only 32 bits. When you have 32 bits, your availability of IPs are limited. Limited in the sense you get some around one close to I don't remember exact number, some around around 1 billion IPs you get, but one in the range of 1 billion. But when you have IPv6, it's actually 4 times bigger than your not yeah 4 times bigger than your IPv4, because when I say 4 times bigger, uh, IPv4 only has 32 bits, but IPv6 has 128 bits. So when you have 4 times bigger than the IPv4, you don't get a not like 4 billion IPs. This is actually exponential. You get a lot more than 4 billion. So like you're having additional close to a lot of different what do you say bits in additional. Everything works exponentially. Yeah, you don't just simply multiply like 4 times higher than the IPv4. So when you actually calculate, so you get a close to lot of IPs. I don't think we might need another IPv8 or IPv12, something like that. IPv6 would be more than enough for our future. So that in fact that has enough IPs. But in future, maybe 5 years, 10 years down the line, we might have to use these IPs. So IPs will look like this IPv6. But in fact, maybe Google has in Hyderabad, they have some servers. They might already started using this IPv6. So that's how I got this IPv6. So yeah, so the other ones that we saw is IPv4 itself, but this is actually IPv6. Probably they might be started using this. So I got a different IP altogether. So in Hyderabad, I got different IP. In Chennai, I got different IP. In Pune, I got different IP. So so that is how they maintain multiple. That's how the Google high level Google. Do you see anytime Google is down? Very rare, right? The reason being they have huge servers located across the globe. In Hyder, so you are seeing a difference from Hyderabad, Chennai to Pune itself. In Hyderabad, I got a different response, which means the backend server that I'm using is different in Hyderabad. The backend server that I'm using that I access in Pune is different. In Chennai, it's different. That's why you don't see it down. So let's say the machine that is sitting in Hyderabad is down because of some certain reason. So you get a machine from Chennai or Pune or Bangalore. So that's how you see high available. When you have huge list of the backend servers, which actually serves the Google website, even if one machine goes down, even if 10 machine goes down, you don't see the website is down until all of the machines go down. So that all of machines going down is something you'll never see it. So that's why you don't see a Google website down anytime. In fact, Bing also you see the same. Even Microsoft also have the similar setup now. So I think Bing also does the same. So you get, let me ping bing.com. I think it's something not from client side. Probably it's something from my machine side. If I'm let me just do it a different way. My machine itself probably is taking. I have some other way to test. Let me actually do it. Just a minute, guys. Any questions in the meantime? Yeah, this is the IP address for. So this is IPv6. Yeah, of course it has IPv6. That's why I got IPv6. But the IPv4 also it's there. So this is IPv4. Let's compare. It's starting with 142.250. Let us see the IPv that I got. It's 172 from the Pune machine, and from Chennai machine. Let's see what it. It's 142.250.183. I think Hyderabad and Chennai both are getting same. Sorry. Yeah, but not same, but same in the same range. 142.250.196.46, 142.250.183.74, kind of in the same range. Probably they both are sitting in same data center, but two different machines. So that's how actually it's working. Is it clear to you guys regarding DNS?
Yes, Shekhar.
Great. So yeah, I think for today, I think I don't want to actually cover too much. I don't want to actually because it's a first day. So I think 2 topics would be good enough. Next Saturday, I'll actually cover networking basics, and then yeah, storage. We really don't have much to cover. But while I'm covering concepts, I'll cover then and there. But networking is an important topic where I'll actually cover IPv4, IPv6, TCP protocol, UDP protocol. Then yeah, important concept like load balancing, firewall setup, and all this stuff. Yeah, so don't miss Saturday's next Saturday's session, because very important topics I'm going to cover, because networking is a key thing in IT. Storage is something at least storage, compute, servers, virtualization is something you will easily able to understand, because when someone explains to you, you can easily able to understand, but and also easily able to troubleshoot as well. You can troubleshoot as well easily. But when it comes to networking, if you don't have a good basics, it is difficult for you to troubleshoot. So you'll have to struggle a lot to actually troubleshoot it. So that's why it's really important to actually uh, have some strong foundation on a networking side. So next Saturday we'll actually spend time onto this, and please don't miss next Saturday session. And then we'll actually start with our session. So I've shown this actually. I've shown that in a demo. I told you the curriculum, right? So the curriculum won't be serial way. It's actually simultaneous. So I'll tell you what I mean by simultaneous is. Uh, Before, let me actually show the curriculum. Then I talk. So I've shown this curriculum, right? So this curriculum actually not a serial. Like I cover Linux, and then I cover Windows, Azure, then I cover Bash, Terraform. It's not a serial way. It's not linear. It's actually I would say parallel. So we cover, because before you reach Linux, you have to get some Linux machine. So then first we'll actually create a virtual machine in Azure, then a virtual Linux machine in Azure. Then we will start actually using it. So but once you create a VM, you doesn't stop it there. In Azure, you have a lot of things to cover. We'll also cover them. So everything goes parallelly. It's like incremental. You learn something in Linux, whatever you learn, that you're actually going to use it in later stages. And you learn something in Bash scripting, that scripting you're going to use it in incremental fashion. Everything. So in Terraform, use Terraform. How to write Terraform? You learn Terraform code, and then you actually deployed some infra. So that doesn't stop there. You'll actually use it incrementally to actually deploy, destroy, manage in a future classes. So that's what we are going to do. It's not serial. So I just want to let you guys know about that. So everything. Yeah, that's about it, guys. Today, I think we are actually winding up a little early. I'm just giving some time back to you. Probably it's Vinayak Chavithi, if you guys have some plans. But next Saturday, we'll actually cover networking, and then we'll actually cover rest of the topics. Pretty much virtualization basics and DNS basics are pretty much important. We have covered them. Any questions that you guys have? Yeah, in case if you guys don't have any other questions, probably we can wind up this session for today. And those who are interested to actually continue this session, so as I said earlier, please please do reach out to us, and or else we will reach out to you. Please do actually, as I said, please do some initial, commitment payment, so that, and then later, maybe next weekend, once you complete next weekend, so once you're fully actually confident about this training, then you can actually pay remaining amounts. So you can either, you can actually reach out on this number, or else we will reach out to you. So for this, any questions that you have, you can always reach out to me on this number. Or else, if you want to drop an email, you can always drop an email on this email address. And if you want to chat with me in WhatsApp, you can simply just, use this link to chat with me directly. Those who prefer to chat, so you can directly chat with me.
We don't see the screen actually, what you're trying to show.
Actually, I pinged in a Teams channel group. So
Okay,
in
thank
Teams
you.
chat, I actually pinged these details. Can you see it now? The down, right down in my screen, I've shown something.
Yes, yes.
Yeah, so you can reach out. I pinged in your chat. This is where you can even open your chart window. I pinged my contact details, then email address, and then if you want, in case if you preferred WhatsApp chat, you can just use this link. You can use this link to actually chat with me. In case if you have any questions, queries, anything as such. How you can chat is something I'm just going to show. So the moment you open, you will be able to chat with me directly. Because it's from Chennai, I got Tamil language. So, but ideally, should be able to chat with me. Any questions, guys? Are we good to wind up today? How many of you are interested to see the Hyper-V setup, the virtualization, actual virtualization setup? Are you guys interested to see?
Yes.
Yep. Yeah.
Okay, so this is a server. I'll quickly set that up and show it to you. This is a server, Windows Server 2022, which is the latest one out in the market. So you go to roles, you go to next, Windows Server 2022, next. So you see something as Hyper-V. You enable this role, go to next. That's all. You simply, so here you're seeing something like virtual switches. Virtual switch is nothing but virtual NIC, network interface card. You're physically, you'll have some NIC, but you're actually creating virtual NIC. So you can choose which NIC you want to go with. So you can either choose this one or you can choose both of these. Then migration, do you want to enable some migration setup? I'm actually not choosing because I don't have any other. I only have single standalone VM. I don't have a secondary VM to actually migrate from here to there. And where you want to store your disks. So that's important thing. So in that case, I'm actually storing my temporary disk. I think temporary disk, yeah, that's fine. Let me create one folder, Hyper-V. I think if I create on a temporary disk, I might lose the data. So let me go with this setup, Hyper-V disks. And where you want to store your configuration files. So basically your disks will be actually created here. Next, and I'm choosing restart if needed. To enable this role, if you need a restart, I'm actually giving permission to restart as well. So it doesn't take much time. So let's actually. So this is actually a product software from Microsoft to enable virtualization. So we can even create a VM as well. I mean, that's again, I leave to you guys. If you guys want to spend that remaining 20 minutes time to see this virtualization. I can even actually create one VM and show to you guys. But in your DevOps role, you don't do this. Again, I'm saying this.